Thank you, Maitane, for the intro, and thank you all for being here today and allowing me to share with you some of our work. So as Maitane mentioned, I'm a research scientist, part of the City Science group for practically the last decade. And today I want to share with you some of the work that we do around CityScope, and what I'm sort of running here is what you probably have seen in the first session. This is our demo space in the CityScope area. And as I mentioned, over the past decade, we develop and build CityScope in the group. And today I want to share with you some of the work and sort of give you a broad overview of why and how we build CityScope. But I want to start actually with a bit of myself. I started as a designer, as an architect for a decade before coming to MIT and to the Media Lab. And I was actually fortunate to be working on large public and institutional projects in the Middle East, EU, and the United States. And these are really the projects you want to do as a young designer, as a young architect, working on museums, galleries, libraries. But the more I worked on these projects, the more I became aware to the fact that this is not how most of the world is being planned, designed, and developed today. In fact, when we look into patterns of modern urban development, and when we acknowledge the fact that by 2050, 2.5 billion people will move into new cities around the world, cities which are nameless and we do not know where they are and how they're going to build, we have to ask ourselves why it is that we build new cities and develop existing cities the way that we do. Is it a technological limitation? Is it an engineering challenge? Are these economic constraints? What forces us to build those cities in that manner? Now, I'm not here to answer all of these questions, but I think we can start and focus on some of the challenge through this slide. These are 3 moments in the history of Los Angeles zoning code. As you can probably imagine, in 1916, I would be able to read it in one afternoon and design the city by the evening. In 2011, I wouldn't be able to even grasp the entire amount of paper trail, and not to mention reading it through a year. The thing is that traditional planning processes in those cities became slow and bureaucratic, filled with legal terminology, which in place favor top-down and highly centralized design processes in which collaboration, participation, and public engagement were deeply and rootly undesired. These ideas and these issues with contemporary planning processes motivated myself and our team to think about an alternative planning process, and we collectively call it CityScope. This is an urban modeling, socio-technical urban modeling and simulation platform, which we, as I mentioned, developed over the past decade. And I think it's important to emphasize that CityScope is not a tool, despite the fact that you have seen some incarnations of CityScope. CityScope is more of a design and planning process, which favors bringing people together and bringing the community as part of the decision-making process. Now, we like to look at CityScope into these 4 themes: insight, transformation, prediction, consensus. These are hand-wavy terms for an afternoon session, but for the rest of my talk, I'll try to take you through some examples for each. So what do we mean by insight? When we think about insight, this is how we understand the current state of the city and try to represent it. So we started pretty obviously with urban observatories, showing different layers of information such as land use, road network, solar panel and wind, etc. But quickly after, we started looking into the urban dynamics through the collaboration with the city-state of Andorra. I think you heard about Andorra already. This is a tiny city-state in between Spain and France, about 80,000 inhabitants. But a few times a year, they have huge events. And through a collaboration, we gathered anonymized, countrywide, few years of location data. And when we had that data, we could start and understand behaviors of both tourists and locals, pinpoint hotspots, congestion, and other behavioral patterns during those large public events, Cirque du Soleil, Tour de France, and some other events. With a bit more accurate data, we can start and model different correlations between activity patterns, urban form, amenities, and other spatial features, so that we can show which of these urban ensembles, an ensemble would be a restaurant, a coffee shop, an intersection, and and urban activity that we can see from the telecom data, which of these create highly active urban places. Now, this is done for tourism, but during COVID, we basically flipped that metrics, and instead of looking at places where we want people to come together, we started looking at what is the potential of a place to create the opportunity of contracting COVID. So on the left side, you can see pre-lockdown potential for two people to meet in the same place, and on the right side, after lockdown, and again, using the same data pipelines. Similarly, a project we currently do in Concepcion in Chile, where we look into behavioral patterns of commuters from San Pedro to the city of Concepcion. You can see how the behavior, just from tapping into the telecom towers, give us indication of where people spend most of their days as a valuable transportation insight. Now, I talk about insights, but we never keep those insights on the screen. Instead, we build them as tangible decision support system and put them in the city. In this case, as you can see, in an innovation center we built in Andorra, used by the public, used by decision makers, as well as researchers to expand upon other insights of the city. So we talked about insights. This is how we understand the current state of the city, but what we really want to do is to change and move from that initial state to where we want the city to be. So this is the second phase transformation, in which we use CityScope as an iterative, real-time, and interactive decision support system. And of course, CityScope was not designed in a vacuum. This is standing upon the shoulders of giants of the last 6 or 7 decades of developing this notion of urban HCI, or urban human-computer interaction, starting here at MIT in 1962 with the Sketchpad and going all the way to the 90s with Hiroshi's work, also in the third floor, developing those urban HCI systems. That motivated us to extend our CityScope platform and allow different stakeholders in community to explore different scenarios, from new zoning, land use, public and open spaces, to new mobility modes, and then evaluate each one of these scenarios through the same metrics and KPIs. And Marcus there on the back is going to talk to you a bit about the metrics for which we evaluate our CityScope. But the idea, what I think you need to imagine here, is it's regardless of which urban intervention we propose, new buildings, new parks, or new mobility modes, we can investigate them through CityScope. But what happens in the lab sometimes have the opportunity to be tested in real world. So in 2017, we were tapped by the city of Hamburg and were asked to help them with the development of a new site called Grassbrook. This is Hamburg's future innovation and entrepreneurship neighborhood, which is very close to the city center. Here, the city of Hamburg did not want us to design the site per se, but instead to use our CityScope platform to evaluate different design proposals from star architects all over the world and run them through the same set of metrics and KPIs in what we would call an apples to apples comparison. So on the left side, you can clearly see the designer's proposals, very arbitrary. Each designer worked in their own way. But then on the right side, you see sort of the simplification of CityScope through which we evaluate each one of these designs. Now, specifically in that case, we evaluated each design through noise, stormwater runoff, access, as well as GFA. I'm not going to go deep into that, but I just wanted to mention that building this as a real-time platform allowed the judging team, the evaluation team of that competition, to basically see many, many different versions instead of just the version that was proposed to them by the designers initially. That motivated us to extend our platform, build it as an open-ended and open source tool, and then allow different teams and organizations around the world to inherit that tool and build it to their own purposes. Some examples that we show here. And that was actually in a sweet spot during COVID when we couldn't physically build those CityScopes. So that was a good moment for us to explore an online and a distributed system. So I talked about gaining insights, understanding the current state of the city, and changing the city, making transformations from where we were to where we want to be. But now the third step, which is prediction, aims to evaluate the impact of these changes on urban behavior and experience. What I mean by that is that we know the symbiotic relationship between changes to the built environment and how they might impact our behavioral patterns, how we move, how we experience the city. So in this small project called Mocho, we tested the model for mode choice modeling. That's basically how we choose to move in the city. Should I take a bike or public transportation or private car? And we wanted to demonstrate how micro changes to a neighborhood, as you can see on the bottom right side, would impact the mode choice for the entire metropolitan region. Similarly, again, in Hamburg, we tested an agent-based model to investigate the impact of microscopic interventions to the mobility habits of maritime tourists. So we basically checked what happened if we change a turnstile or some signaling within the major train station in Hamburg and how that would affect those agents as they move through the center of the city. And lastly, again, during COVID, we did a project on the Champs-Élysées Boulevard in Paris. You're probably all familiar with this famous boulevard in which the city is planning renovation, removal of some car traffic, as well as changes to commerce and green spaces. And again, we were not designing the site, but we were using an ABM in order to evaluate the impacts on those changes on both locals, tourists, etc. So I talked about the changes to behavior, but every once in a while, what we want to predict is how people might perceive the city, how they might experience it through the point of view of the user. So you can see Marcus here modeling for that CityScope platform. And the idea here was to use what I think today would be called an ancient technology. These are generative adversarial networks. To those of you who are familiar, basically a generative model that translates the design of the users to real-time images of the city. To those of you who are familiar with Kevin Lynch's work, basically a street view image in real time from that location. Now, as I mentioned, this is ancient technology. It doesn't look very good, but last year we've been revamping this project through the immersive scope, which you'll all have the chance to experience today. Here we again use more advanced generative models, diffusion models, and the team, and Letty's going to talk deeply into that, so I'm not going to go really in depth, but the team here explored different interfaces such as auditory interfaces in order to affect what we see in the final result. And as I mentioned, we're using some of the newer models here that will allow us almost in real time to generate compelling street view and environmental images, videos, and visuals. Something we work on right now, and this is the last project I'll show in the context of prediction, tries to bring the two together. So I talked about how people move and behave, and I mentioned the experience we have while moving through the city. But in this project, we try to bring them together through the usage of large language models. And we're building what is known as a travel agent, which is a fictional person, as you can see the profiles on the left side, which is then fed by some profile and some background, and a task. It could be anything from walk down the city for leisure or meet a professor in the university or do anything else. But the purpose here is not to fulfill perfectly that mission or that goal, but instead to investigate how that agent experienced the proposed or existing built environment. So just as an example, here we have two tests with the travel agent. They move through a fictional media lab environment and they're supposed to meet their professor at a certain point. What they're being fed with are those fictional street view images or building images, and they make a decision based on what they see and the information they have from before. And here, this is an exterior version. The task here on the top was find a shaded place to have lunch. On the bottom was cross the street safely. And as you can see, it crosses in a diagonal, completely unsafe, although it looks left and right before they start crossing. So that's actually an interesting decision, maybe driven by safety or something else. And as you can imagine, with more complexity here, we can investigate fictional and future built environments which are not there yet. But I haven't talked up until now at all about the public or about creating collaboration through these tools. And I think that's the most critical part, because everything I showed you up until this point could have still happened behind closed doors within the underground parts of a city hall without any observability to the public and to the stakeholders. And so the last two projects I want to share with you today deal with that part of consensus and how we can pack CityScope as a public-facing decision-making process. One of our first out-of-the-lab CityScope projects dealt with using CityScope for public participation in the context of building BRT routes. BRT is bus rapid transit, basically an enhanced mass transit system that in 1/10 of the cost of a light rail offers prepayment and improved bus stops and other cost-effective alternatives to public transportation. In the use case of the city of Boston, we have seen about 5 of these corridors meeting in one point in the center of Dudley Square. This is historically vibrant, blue-collar, well-served community. But during the 1980s, the MBTA decided to demolish the station and relocate the station about a mile to the north, and basically supporting an ongoing deterioration of that environment. Now, a quick disclaimer, the next slide is a bit triggering, but this lady is in a good shape. She's just part of a big protest against some of these transportation projects. And that was really the scenery, the environment that brought us into this project. And once again, the city of Boston and the Bauer Foundation, when they invited us to join, they were not asking us to be the planners for this BRT project or BRT routes. Instead, they wanted us to create a co-creation process in which we are bringing communities, we're bringing the public together, and together learn what we can do better in order to improve those plans for the neighborhood. I think one key important thing here to note is that the people that you see here were not just part of a community engagement process, but instead they were working with us from the get-go on designing the participation. And the reason it's important is because their feedback during that process taught us a lot about what the community might need and want in that public participation process. For example, we learned from them that explaining what a BRT system is to begin with requires multiple scales: street scale, neighborhood scale, and then the regional scale. The regional scale was designed as a citywide understanding of the BRT system and the impact of that system on each member of the community. The participants designed their own daily commute and then were given insight about waiting time, access to housing, jobs, and amenities, as well as the ability to make certain modifications to that BRT system. The neighborhood scale used one of our CityScope tangible user interfaces to define the most suitable locations for a BRT station in the neighborhood, while showing different KPIs such as pollution, commuting time, and costs for each scenario. And lastly, the street scale introduced basically what are the impacts or the physical impacts of a BRT system in that neighborhood. Now, for us, and I think this slide is important, the idea was not to focus on the technology, but instead to focus on the people behind the technology. How we can use CityScope as a way to elevate the conversation and begin a discourse around those critical items. And for us, it was also a wonderful platform to the last project I'll show you today that involved CityScope in the heart of a very heated decision-making process in Germany. So in 2015, we began a partnership with the Hafen City University, in which at the beginning, we were asked to look into the upscale development of the Alba riverfront and the design of the Olympic Village, which was at the time part of Hamburg Olympic bid for the 2024 Olympics, as you know, happened eventually in Paris. But in reality, in 2015, all of these sort of first world problems had to be put aside when the city realized that about 80,000 refugees and asylum seekers from North Africa and Syria are embarking with the city. These are 500 people for which the city had no viable solutions at the time. As a result, the public sentiment changed and the mayor's own government became a bit uncertain. So much so that within a few weeks, the mayor showed up in our newly established City Science Lab in Hamburg and told us, you have a small budget and about 3 months to come up with a solution, giving us only those 3 criterias. And just for reference, this is the City Science Lab in 2016, 2.5 people. We literally just started. But within those 3 months, we have basically copy-pasted everything we knew about public participation, engagement, and CityScope to Hamburg. And as you can see here, the mayor inaugurating Finding Places, positioning the first Lego brick in what in the next 3 months would become Finding Places project. I like this quote from the Zeit newspaper who was saying, this is swarm intelligent, doing instead of complaining. If you want to complain, stay at home. If you want to take active part, come and be part of Finding Places. And indeed, over the next 3 months, we had about 400 participants with 30 community meetings. Each of these sessions started with, first of all, getting insights, as I mentioned at the beginning, insights about the current state of refugees in the city of Hamburg. And then the team would transfer into an interactive CityScope platform. On that tool, every time an interaction would happen, a GIS system would offer real-time feedback on zoning, land contamination, access, and some other KPIs. And finally, that team together can reach a conclusion on what are the best places to host those refugees. Overall, Finding Places has a measured outreach of about 1.2 million residents in Hamburg and identified over 160 sites. Some of these began construction while we were still doing those community engagement events because we removed the general public consent, which was the most challenging part. Olaf Schulz is currently the Chancellor of Germany, to those of you familiar. And I think his statement about Finding Places is wonderful, not just for that project, but generally for CityScope. Here is your chance, Schulz is saying, to examine whether what makes sense in theory is also suitable in practice. And again, I think it's followed through all the projects you've seen here today. And again, Finding Places today is being used by these organizations for their own refugee and immigration challenges across Europe. And that's just part of the work we've been doing with all of our City Science Network labs around the world, basically using CityScope for different purposes. But in each case, even if the technology is similar, the questions are very, very different. And I think that's the beauty and agility of CityScope. Maitane, how much more time do we have? I think we're in the last minute. Can't hear you.
Yeah, I think like 5 minutes or...
Okay, I've got just 1 last minute on my end.
Yeah.
Okay, awesome. And so I just want to close because I started by asking, how can we move from smart city to street knowledge? How we can move away from what was the big promise of urban technology about a decade ago to something that really understand and take in consideration what the city actually needs. And so I think that you look into this technological moment and move from technology that is focusing just on the optimization of cities and the built environment into technologies that can augment the human experience in the city. I believe that we can go from top-down and highly centralized design processes to harness technology in order to crowdsource and amplify the voices of many. And lastly, I think that we can move from smart cities to potentially street knowledge as a way to collectively govern the wonderful mess cities could and should be. And I give those 2 examples because this is the smart city of Songdo in South Korea. As you can see, probably not the most pleasant place in the world. And on the right side, this is just Seoul with its all beautiful vibrancy. And with that, happy to take some of your questions, or we can move on to the next speaker. Thank you.